Hello friends, today we will discuss about I/O interfacing, how we are going to interface any input and output device with any of the microcontroller. This is going to be a part 1. So whenever we are going to connect any input device or output device, we want to connect those devices to microcontroller I/O pins. So there are two different logics we are going to have it. One is internal pull-up resistance logic and another one is external pull-up resistance. So now we are going to say what it is pull-up resistance. Say normally for any port pin of any microcontroller, it is going to have the driver. So this that driver may be a CMOS device or BJT. So now you take this as simple BJT to understand. So the emitter gets connected to the ground, and whereas the base is from the microcontroller data bus. So if I am going to connect this resistance externally, maybe 10 kilo ohm resistance, and if I apply 5 voltage to the one end, what is going to happen the output at this particular point? So if I am going to connect any bus to this base, and based on that bus value, we are going to have the change in output, because this is going to be a series circuit. So what will happen if I give the base voltage as 0? So whenever I am going to connect base voltage to base voltage as 0, then by default the transistor goes to cutoff region. So if that means the cutoff region, in the sense it is going to be no conduction state. So if it is no conduction state, then there will not be any current flow between collector and emitter. So now let us see what is the voltage we are going to get it. So as per the formula, it is going to have V equal to I into R. Now since this transistor is in cutoff region and there is no current flow, and what will happen to I? It is going to be 0. So if I goes to 0, since because of the base voltage is 0, then there is no voltage drop across the resistance, or there is no drop across this particular circuit. So and there is no drop. If there is no drop across this particular R1 resistance, then what happens to the applied voltage? So the entire applied voltage comes to this point because of the open circuit configuration, and the current value is 0. So now let us have the other option. If I connect the base value as 5 voltage, that means from the data bus, if I receive the voltage or the data as logic 1, then what will happen? This transistor goes to saturation region. So once if the transistor goes to saturation region, then there will be a current flow between collector and emitter. So again same formula, V equal to I into R, and base voltage is 5, and the transistor goes to on. So once the transistor goes to on, there is no resistance across this emitter and collector. So it means that it is going to be almost a short circuit. So if you are having almost a short circuit, then the resistance value is going to be very low values. So there is no drop across the transistor, and if I connect that means there is no drop across this resistance, but if I take this one, you will be having the current flow from this. So almost this particular end is going to connect it to the ground. So once if it is getting connected to the ground, the voltage is going to be 0. Okay, now let us see what it is pull-up resistance. So this I connected externally, and that is normally it is going to have the high voltage value. Because of that factor, we call it as pull-up resistance. So most of the microcontrollers internally they are going to connect that resistance, they call it as internal pull-up resistance. If that is not there, then externally we can connect, and you can have, or you can name it as external pull-up resistance. So let us see how we are going to use this particular concept for accessing of your input device. So here I am going to consider keypad, matrix keypad. So say if you take your mobile phone, through your key matrix we are going to send our data to the internal CPU, and if you take this mobile phone, again through this buttons, external switches, we are going to send. So similarly if you take this ATM machine also, we are going to have the matrix. So if you take this ATM machine, it is going to have 4 cross 4 requirement. If you take this normal telephone, here also we want to have 4 cross 4, and if you take this one, this is going to be 4 cross 3. So depends on the applications, we are going to select the size of keypad. So there are a lot of applications are there where we want to give or we want to apply this keypad. So for ticket vending machine, fingerprint machine, and so on. Okay, now let us see what is going to happen internally. So this is going to have a 4 cross 4 matrix. So that means why they call it as matrix. So in terms of row and column wise, we are going to have the connections. So because of that, they call it as matrix. So if I want to have 4 cross 4, then I am going to have 16 different combinations. So depends on the applications, we are going to select the type of or the size, matrix size. So say if I have this matrix, then row and column wise I want to access the information through my microcontroller. Say maybe port X and port Y. Here I have taken port 1 and port 2. So via these two ports I am going to access my information. Okay, now please remember the previous concept, that means pull-up resistance concept. Say this is my resistance I have and this is the switch. So instead of transistor I am going to connect one switch, and there may be a different configuration. So this is I have in terms of vertical and this is in terms of horizontal axis. So whatever it may be the case, the circuit is remain same, there is no change. So please can you identify what is going to have the output voltage at this particular point, that is V out. What is the V out voltage here? So most of the time we say that it is going to be 0 voltage. No, that is wrong, because say this is going to be 5 voltage. This is going to be 5. Why 5 voltage? If the switch is in, say for example, open, that is open, then there is no current flow through this resistance, through this switch, and you will be having the voltage up to this point and there is no current flow. So by default you are going to have the entire voltage. As per my previous statement, there is no current flow through this, since because of the open circuit. So if there is no current flow, then there is no drop across the resistance. So there is no drop across this resistance. The entire voltage comes to this particular point. So that is why we have 5 voltage. Now what will happen if I press the switch? So whenever I am going to press this switch, it means that I am going to have the connection between this V out terminal and the ground, as well as the resistance other end to the ground. So please remember, this is my output V out. So one possibility is maybe you can have 0 or 5 or between 0 and 5. So now let us see what will happen if I press this switch. So whenever if I press this switch, it is going to have 0 resistance here. If there is no resistance, that means the 0 resistance value, that means it is going to be a short circuit. So if it is in short circuit, that means your ground is going to dominate than this supply voltage. So what will happen to the output voltage? Can you guess? So most of the time we are taking the logic called positive logic, or we call it as positive psychology. That means if I press switch, it is going to have 5. No, that is not correct. Because of this closed path, this ground is going to dominate than this supply voltage. So now I am going to have the output as 0. So now we understood that there are two different logics we can follow. One is logic high and logic low. So through this logic high and logic low only, any processor or controller is going to recognize the status of the input and output device. So if I have the internal pull-up resistance, and this is going to be the result, that means that the pull-up resistance may be internal or external. So by default the data bus is going to carry the voltages high. Then by default I want to connect the ground to the other end via my input system. So without having any connection, I am going to have logic high. If the connection goes to closed circuit, then it is going to, it is your microcontroller required the other state, that we call it as 0. This logics normally we call it as negative logic. Most of the microcontrollers and IO devices all the developers, they are following this negative logic because it is going to have only the ground in the output side. So then let us see another simple logic, key debouncing. So normally in theory or in the statement we call it as high and low, but if you take the practical case, whether we are going to have the same kind of, say for example, if you take the first one, the logic, the first, if the switch is in off state, you may have the logic output as high. Once the switch goes to on, the logic output goes to 0. Whereas the other case, normally the output may be 0. Whenever if I am pressing the switch, it goes to 1. That means if I release my switch, it may go to this off state. So this is the case. Okay, either you can follow positive logic or negative logic, whatever it may be. But in practical, it is not going to happen. Say for example, if you take this push button, any material in general in physics that will have its own elastic property. Plastic may have higher elastic property than other materials. So if you take this particular push button switch, internally we may have the metal to make the connections. So if I press the button, it may go to low, but that may be in theory we call it as it goes to low, but it is not going to happen. After pressing the switch, we are going to just release it. So within microsecond, it goes again bouncing back to high, again low, again high, then only it is going to settle down. So this value or the number of bounces depends on the elastic property of that particular material and how you are handling your switch. Even if you are, whenever you are going to operate your electrical appliances like mixie, grinder, washing machine or your iron boxes, sometimes you may get the spark while switching on your devices. Since because of that internal elastic property, you will be having the contact high, low, high, low. It means that we are connecting, disconnecting, connecting, disconnecting, so that we are going to have the spark. So here your microcontroller is going to identify each and every state because it can respond all the changes within microsecond. So according to us, it is going to have only one on, but according to the microcontroller, this is off state, it goes to on state, then again off state, again on state, then again off state, then off state. So according to this microcontroller, it says that 1, 2, 3. 3 times you have switched on this particular push button. This effect we call it as debouncing effect, or we call it as key debouncing effect. So to avoid this key debouncing effect, we want to give some kind of technique. There are two techniques we are going to follow. One is through microcontroller, through program we are going to have it, or we are going to nullify, or by means of external circuit we want to nullify it. Say through my microcontroller, once the microcontroller identifies the switch goes to on, then I want to make delay up to this particular period. So up to this period, if I make delay, then your microcontroller is not going to respond for this. So by default, it is going to consider the number of time as 1. Or you can have the external capacitance which is going to avoid this particular key bouncing, but that is going to be a costlier than the software. So normally the programmer is going to adopt this kind of techniques to avoid this key debouncing effect. So thank you